Good morning, children. How are you all? Good? As you all know, children, we have started lesson number 2, work and energy. And in our previous lectures, we have studied about work, energy and different types of energy. Today, children, in this video, we shall be learning about transformation of energy. Children, can you tell me which are the different forms of energy? Which type of energy is used in each of the following processes? A stretched piece of rubber. Second, fast moving car. Third, the whistling of a cooker due to steam. Fourth, the crackers exploded in Diwali. Fifth, a fan running on electricity. Sixth one, drawing out pieces of iron from garbage using a magnet. And seventh one, breaking of a glass window pane because of a loud noise. So children, energy can be transformed from one type to another. For example, exploding firecrackers convert the chemical energy stored in them into light, sound and heat energy. Understood? Law of conservation of energy. Energy can neither be created nor destroyed. It can be converted from one form into another. Thus, the total amount of energy in the universe remains constant. So children, this is the law of conservation of energy. Okay? Now, to understand this, let's try an activity. Make two pendulums of the same length with the help of thread and two nuts. To another thread, tie it in the horizontal position. Tie the pendulum in this horizontal thread in such a way that they will not hit each other while they are swinging. Okay? Now swing one of the pendulum and observe. What do you see here, children? You will see that as the speed of the oscillation of the pendulum slowly decreases, the second pendulum, which was initially stationary, begins to swing. Isn't it? Yes. So, one pendulum transfers its energy to the other pendulum. Understood? Now let's study free fall. If we release an object from a height, it gets pulled towards the earth because of gravitational force. Right? Yes. An object falling solely under the influence of gravitational force is said to be in free fall or to be falling freely. Now, let us look at the kinetic and potential energies of an object of mass m falling freely from the height h when the object is at different heights. Okay? As shown in the figure, Point A is at a height h from the ground. Let the point B be at a distance x vertically below A. Let the point C be on the ground directly below A and B. Let us calculate the energies of the object. When the object is stationary at A, its initial velocity is u, that is equal to 0. Therefore, kinetic energy is equal to 1 upon 2 into mass into velocity square. Right? This is the formula for kinetic energy is equal to 1 upon 2 mu square. Since here velocity is u, so therefore kinetic energy will be equal to 0. Potential energy is equal to mgh. Therefore, total energy will be kinetic energy plus potential energy. So, kinetic energy is 0 plus potential energy is mgh. So, what we will be getting the total energy as mgh. Let this be equation number 1. Now, let the velocity of object V when it reaches point B having fallen through a distance x. Okay, so what will happen here? U is equal to 0, S that is displacement is x and acceleration due to gravity it is g. A is equals to g. So here we will using V square is equal to U square plus 2AS. Vg square is equal to 0 plus 2gx. So Vg square is equal to 2gx. Therefore, kinetic energy is equal to 1 upon 2 mvg square, right? Which is equal to 1 upon 2 m 2gx. We are substituting the value. Therefore, kinetic energy is equal to mgx. Understood how we got this? Good. So, height of the object when at B is equal to h minus x. Therefore, potential energy is equal to mg into h minus x. Are you getting me, children? Potential energy is equal to mgh minus, which is equal to mgx. Therefore, total energy, kinetic energy plus potential energy. Understood? Good. So, what we can say here? mgx plus mgh minus mgx. So, therefore, total energy will be equal to mgh, right? Both mgx and minus mgx will get cancelled. Let this be equation number 2. The third one. Let the velocity of the object dvc when it reaches the ground near point C. Okay, so what will happen here? U is what? Is it equal to 0? S is equal to h and A is equal to g. We will be using formula V square is equal to U square plus 2AS. So, V square is equal to 0 plus 2gh, which is equal to 2gh. Therefore, kinetic energy is equal to 1 upon 2 mvc square, which is equal to 1 upon 2 m into 2gh. We are substituting the value. So, what are we getting? Kinetic energy is equal to mgh. So, the height of the object from the ground at point C is h is equal to 0. Potential energy is equal to mgh, which is 0. Therefore, total energy is equal to kinetic energy plus potential energy. So, what would be? Yes, mgh plus 0. So, total energy is mgh. Let this be equation 3. So, from equation 1, 2 and 3, we see that the total energy of the object is the same at the 3 points A, B and C. Have you all understood? Thus, every object has potential energy when it is at a height above the ground, and it keeps getting converted to kinetic energy as the object falls towards the ground. Isn't it? On reaching the ground, point C, all the potential energy gets converted to kinetic energy. But at any point during the fall, the total energy remains constant. That is, we can say total energy is equal to potential energy plus kinetic energy. Total energy at point A is mgh plus 0, which is equal to mgh. Total energy at point B is equal to mgx plus mg into bracket h minus x, which is equal to mgh. And total energy at point C is equal to 0 plus mgh, which is equal to mgh. Understood? Very good. Now let's study what is power. Children, can your father climb the stairs as fast as you can? Will you fill the overhead water tank with the help of a bucket or an electric motor? Suppose Rajashri, Yash and Ranjit have to reach the top of a small hill. Rajashri went by car, Yash went cycling and Ranjit went walking. So what is the difference? What will you find here the difference? Yes, if all of them chose the same path, who will reach first and who will reach last? Think, children. In the above example, the work done is the same in each example, but the time taken to perform the work is different for each person, or we can say each method. The fast or slow rate of the work done is expressed in the terms of power. Power is the rate at which work is done. If W amount of work is done in time T, then power is equals to work upon time. In SI system, the unit of work is joule and unit of power is joule per second. So this is called as watt. 1 watt is equal to 1 joule per second. In the industrial sector, the unit used to measure the power is called horsepower. Are you getting me, children? So 1 horsepower is equal to 746 watt. The unit of energy for commercial use is kilowatt hour. 1000 joule work performed in 1 second is 1 kilowatt power. So 1 kilowatt per hour is equals to 1 kilowatt into 1 hour, which is equal to 1000 W into 3600 seconds, which is equal to 360000 joule, or else we can write this as 1 kilowatt per hour is equals to 3.6 into 10 raised to 4 joules. Electricity used for domestic purpose is measured in units of kilowatt hour. So 1 kilowatt hour is the 1 unit. Got it? Let us see some solved examples which is there in your textbook. First, Swarali takes 20 seconds to carry a bag weighing 20 kilograms to a height of 5 meters. How much power she has used? Okay, we need to calculate here. She is carrying a bag which weighs 20 kgs and she needs to carry that bag up to a height of 5 meters. So what is given? Mass 20 kilograms, height 5 meters and time is given 40 seconds. Therefore, the force which has to be applied by Swarali is F is equals to mg, which is equals to 20 multiplied by 9.8. So F is equals to 196 Newton. Work done by Swarali to carry the bag to a height of 5 meters is W is equal to Fs, which is equals to 196 into 5, that is 980 joules. Okay, understood? So what is the power formula? Work upon time, that is 980 divided by 40. So what is the answer will you get after calculating? Power is 24.5 watt. Second, a 25 watt electric bulb is used for 10 hours every day. How much electricity does it consume each day? Understood the problem? Okay. What is given, children? Power is 25. Work, it is 0.025 kilowatt. We have converted into kilowatt. Okay. Therefore, energy consumed is power into time. So, 0.025 into 10. So what are we getting after calculating this? Energy is equal to 0.25 kilowatt per hour. Understood, children? I hope every one of you must have understood the lesson. Children, kindly watch the video attentively and then read the lesson for better understanding. We shall meet you in our next lecture with a new topic. Till then, take care of yourself and your family. Thank you, children.